Hi, in this video we are going to talk about the heap sort algorithm, so let's get started. Basically, it is a comparison-based sorting algorithm such as merge sort, bubble sort, quick sort, or insertion sort, and it uses heap data structure rather than a linear time search to find the maximum item or the minimum item, for example, and we keep repeating this process again and again. So we keep looking for the maximum item, then if we find it, then we set it to be visited, so we are not going to consider that given item over and over again. It is a bit slower in practice on most machines than a well-implemented quicksort, but on the other hand it has the advantage of a more favorable worst-case runtime, which is ordo n log n, so linear arithmetic. It's very important that it is an in-place algorithm, so it doesn't need any additional memory, but on the other hand it is not stable, so it's not going to maintain the order of the items with the same keys. Okay, the only problem is that first we have to construct the heap itself from the numbers we want to sort, and it's going to take ordo and linear time complexity because we have to consider every single item. So what about the heap sort algorithm itself? We have a heap like this, and we keep swapping the root because it is a heap. We know for certain that the root is the item with highest priority. So for example, if we are sorting integers, then the greatest items, so the maximum number is going to be at the root node. So we keep swapping the root node with the last item. Plus, we have to maintain the heap properties, so we have to reconstruct the heap data structure if we come to the conclusion that the heap properties are violated. In this case, we are dealing with a maximum heap, so the root is the item with greatest value in the whole heap. Okay, so as you can see, the greatest item is 210. Because it is a maximum heap, the children are smaller, so 123 are smaller than the parent. In this subtree, it is also true the parent is 100, then the left child is 2, right child is 5, so the parent is the greatest one in this subtree. First, we have to swap the root node with the last item. The last item is 5, the root node is 210, so we just swap them, and we consider this item to be sorted. So after swapping with the root node, we consider the last item to be sorted, so it's no longer part of the tree, so we don't have to bother about this node. Plus, it's very important that we have to check whether it is a valid heap. It is not a valid heap because in a maximum heap, the greatest item should be in the root, and the greatest item is here. So we have to swap these two items. But in this case, it's going to be a valid heap. We don't have to bother about this already sorted item. Again, we have to swap the root node with the last item, which is the 2. And we consider it to be sorted, so we don't have to bother about these two items. In this step, the heap consists of 3 items, 2, 5, and 23. Again, we have to check whether we have violated the heap properties or not, so we have to swap the 2 with the 23. Okay, after the swap operation, it's going to be a valid heap because the maximum item is in the root node. Then we have to swap the 23, so the root node with the last item, which is the 2. Okay, we have to swap them and consider 23 to be sorted. We have to check whether the remaining 2 items forms a valid heap or not. Of course, it's not a valid heap because in a maximum heap, the maximum item is in the root node, so we have to swap them. Then again, we have to swap the root node with the last item, which is the 2. We swap them, and we consider 5 to be sorted. So we don't have to consider these items anymore, and we have a single root node, so it's going to be the last item in the sorted order. And as you can see, 210, 100, 23, 5, and 2 is going to yield the numerical ordering in descending order. So we have managed to sort the elements. The running time is that we have to consider n items, plus we have to make some swappings if necessary. All the swapping operations will have logarithmic running time, but because we have to consider n items, we have to do it n times. So the overall running time will have ordo and log n, which is quite fine. If you know merge sort or quick sort, this is the running time for these algorithms. So that's all about heap sort. Thanks for watching.